We're going to go ahead and get started. I'd like to thank everybody for attending our webinar today on fibers in concrete, benefits, applications, and dosage rates, hosted by the Illinois Ready Mix Concrete Association. My name is Theron Tobalski, and I'm the Assistant Executive Director. Part of my role is helping the engineering community understand all the different technologies that are available for concrete. And today we're going to highlight fibers. A couple points before we get started. We are following the antitrust statement by the Illinois Ready Mix Concrete Association. It is posted on our website. For every different webinar, we post the antitrust statement there, just so that we're not doing anything like talking price or breaking up areas of the state between the different fiber companies. So those are the rules we will be following. Every webinar is recorded and posted on our website. If you go to www.irmc.org, you click on the webinars tab, you will see all the different webinars listed. We have the presentations posted, we have the recorded webinar posted, and then we have, as you will see here, a bunch of people who have sponsored the webinar. Each one of these companies has listed or will be listing 3 links for you to click on to all different types of technical information. Some could be on fibers, some could be on chemicals, some could be on different types of cement, some could be on different technologies that are out there as well. And with that, I'd like to introduce my 2 speakers. We have Larry Kaiser, who is a PE, Senior Project Manager of Engineering Design and Infrastructure for GCP Applied Technologies, and Matt Norman with Midwest Sales Manager for Concrete Fiber Solutions. And with that, I'll turn it over to Larry Kaiser to start with the presentation.
Good. Okay, everybody see that screen there? Okay, good. Well, thank you very much, Theron, for the opportunity to speak today. I've been doing this a little while, and hopefully we can get through it and have some learn a little bit about fibers and what the applications are and the limitations primarily. But I kind of wanted to iterate that when you guys have questions about this, please hold it to the end or actually write your comments. There's a way to ask questions to Theron, so we'll bring them up at the end. We'll try to get them resolved. So again, we all kind of learn a little bit about this. So one of the biggest thing about fibers is it's kind of a little bit of a misnomer in the industry, and it's a big question mark on a lot of people. It's like, what are these fibers good for? Where can I apply them? And that's we want to get rid of some of that. We want to bring out get everything out in the open here. So let's see if this we didn't check is this thing that trying to make my slideshow go. There we go. Okay. I don't know why it took this long. Okay, so we're going to kind of go through the difference between micro and macro synthetic fibers. And later on, Matt Norman's going to be speaking about macro steel fibers. Okay, but I'm going to primarily focus on the synthetic side of the house. When we go through the difference between the 2 fibers, we'll go through the verifications performance tests. We want to make sure if we're going to put fibers in the concrete, that they're going to do exactly what they say they're going to do. Then we'll go through the applications, make sure we're putting them in for the right purpose. There is a slab on ground design software and pavement design software that's available to you guys, and primarily it's to design any type of slab that you have, whether it's interior or exterior, but it definitely has the capabilities to do that. We'll kind of get into that later on. So the mechanism of a crack, as you can kind of see the picture on the left, is you have a crack starting to migrate in the paste, concrete paste. The fiber basically intersects it and stops it from getting worse, basically. So do you have enough fibers in there? Are they strong enough? Are they long enough to stop that propagation from happening? So nothing earth shattering there. This is kind of neat to see it on the molecular level, really. So microfiber and macrofiber. So the microfibers basically are for the purpose of stopping plastic cracks in concrete. Meaning when the concrete's in its early stages, the first couple hours after you pour concrete, it's basically stopping that from happening. Typically, you're going to have it in different types of materials: polypropylene, nylon, carbon, and cellulose. But the primary purpose, again, is for plastic cracks. Half a pound to a pound and a half per cubic yard is very common. Once in a while, you might have a dosage rate that might be 3 pounds per cubic yard, but typically what I'm seeing is about a half a pound to a pound and a half. Now, macrosynthetic fibers, primarily, or macro steel fibers also, they come roughly for synthetic 3 to 15 pounds per cubic yard. What's typical is usually say 3, 4, 5 pounds. You might see 7.5 pounds for some applications. You would see say 15 pounds or anywhere from 10 to 15 if you're doing tunnels, shotcrete, things like that, where it's more, where you're replacing some pretty hefty steel. Okay. From a steel fiber standpoint, again, Matt will talk about this later, but you'll have anywhere from 20 to 100 pounds per cubic yard for steel fiber applications. So the intent is to have flexural toughness, impact, and fatigue resistance. So the ability to absorb energy is one of the major facets of a macro fiber. So you can really, put the concrete to its test. You can just try to, absorbs a lot of energy. It can take a beating. Okay. But one thing for sure, they are not structural. So they don't replace any structural steel. And I know that there's kind of a misnomer out there. Hey, let's put structural fibers into the concrete. There is no such thing as a structural fiber. Okay. So keep that in mind. There's really only 3 types of steel. There's crack control steel for slab on ground, typically, temperature and shrinkage steel for elevated structures, and then structural steel. All right. So a lot of times people say, what about secondary reinforcement, primary reinforcement? Those are kind of misnomers because it kind of puts you in the direction of being confused, really. So remember those three things I just stated before. So the top picture roughly is a couple of microtype fibers. You have fibulated type on the left, and then monofilament on the right. And they're basically, doing the same purpose, plastic crack control performance only. The ones in the bottom left are macrosynthetic, look like almost like the little mini ribbons. And the bottom on the right are different configurations of steel fibers. So, but they are both considered to be macro fibers on the bottom. So benefits of microfiber, again, plastic crack control prevention only. They're non-corrosive if they're, synthetic. When to use, basically use them when the structures are already reinforced. Okay, so they're going to supplement, be supplemental reinforcement. And slab on grounds currently have crack control steel. So again, the crack control steel is there for holding cracks tight in the long term. Okay, and this is for the short term. So don't use them as a replacement to crack control steel for slab on ground or for temperature and shrinkage or for walls, footings, or ICF. So stay away from that because those are really for macro. So tight crack control basically is the benefit of macro synthetic fibers. So when I say uniform 3-dimensional reinforcement versus 2-dimensional, if I have 3-dimensional, you have fibers all the way through and through. So you have fibers in the top and fibers in the bottom everywhere. So it's almost like having 2 mats of steel. You have the ability to hold cracks tight from, let's say you had reinforcement very close to the top. You have steel on the bottom, which is for load. Okay. 2-dimensional, which means that we just have one single layer of whether it's welded wire mesh or crack control steel in the neutral axis, which really isn't that good as far as for both. It doesn't do very, very well because it's too far from the top and it's too far from the bottom. So it's a good way to have to worry about the positioning of reinforcement just by having macrofibers through and through. Which, same thing for scheduling advantage. You don't have to put the rebar in. It's an additional step in the construction process. If you could just order the fibers with your concrete, then you don't have to worry about it. It's already there. Corrosion is not possible with synthetic products. From a steel fiber perspective, they work just as well as macro synthetics. You could have a bit of oxidation if it's for exterior use, but they still work just fine because it's discontinuous reinforcement. Plastic crack control performance. you know, again, if you have a high fiber count product, typically most companies do, you're actually going to get the benefit of a post crack control, which is the primary purpose of the fiber. And then and you'll also get plastic crack control performance because they have a lot of fibers in there to do that. So, sorry about that, folks. Okay, pumping is easier on equipment. Okay, plastic shrinkage crack control, I've said that before. And then also you can tailgate loads, which means that you can bring your, instead of having to worry about where the weather mesh is or the crack control steel on your slab on ground is, you can just drive your truck right on the subgrade and dump your concrete and work your way out of the facility. So it makes it very easy to pour with macrosynthetic fibers or macro steel fibers. A typical macrosynthetic specific gravity is 0.92, which means it's lighter than water. Okay, so that kind of comes into play as far as finishing. So if I'm going to finish concrete with macro synthetic fibers, they're going to start to float to the top the more I finish it. So you want to minimize the amount of hand finishing you have. Because if you bring that paste up, the fibers are going to come up there and you're going to see more fiber exposed. Okay. Absorption is none, which means it's not going to suck up any water. So they do eat up a little bit of slump. So for the most part, on the average, for every 3 pounds per cubic yard, you're going to lose about 1 inch of slump. Okay. So 6 pound dosage rate, 2 inches of slump. You basically would adjust your mix design and use more mid-range water reducer, or more super to adjust for that purpose. Okay, but you still would keep the same slump requirements. Modulus of elasticity is 1.3 million, which is very, very high. Tensile strength is 90 KSI. So the intent is that when a crack happens, you want to have a high modulus. The higher the modulus, the less it's going to stretch. The higher the breaking strength, the better it is, because less are going to break. Okay, so you want to keep that's related to crack tightness. Okay. So the verification performance test, we have Astm 1609 and 820, 1399, and the 1550. So these are all, you know, we want to make sure the fibers are doing what they're supposed to do. The most common we see to use is the 1609. 820 is for steel fibers. It's basically the same type of testing. And then the round determinant panel test will show you what that is. And that's really to kind of give an even shake to weather wire mesh as you compare it against the fibers. So the 1609 test looks basically like this. It's a simply supported beam, 6x6 20-inch long beam, loaded on its third points. All right. And basically what you have is a crack that's starting to form in the bottom. And we're going to try to measure the amount of load carrying capability or post crack control as that ram goes down and deflects that beam. Okay, so if I didn't have anything in there, I would have no load carrying capacity at all, but I have the fibers and they're basically holding it together. So this shows a little bit about the microfiber. Let's just say that I have load the concrete till it fails, and it fails at 600 PSI flexural strength, and then and the black line represents unreinforced concrete. As that ram goes down and cracks that concrete at 1 millimeter of beam deflection, I have no load carrying capacity, which is unreinforced. With the microfiber, it goes down and it gives me a little bit of performance over here on this board. And then flexural stress, this just means residual flex is post-crack control, how much load is being picked up by the fibers. A microfiber, about 10 PSI, very, very low. I don't have it on here, but if let's say I had weather wire mesh in here, I might be somewhere, even the cheap stuff around, I don't know, about 120, 130 PSI. It would be something like that. So it's way lower below that. Now a macrofiber, basically, this is 3 pounds per cubic yard. This is 5 pounds. This is 7 3/4 pounds. The more I have, the more area I have under the curve, the more post-crack control I'm gonna have out of my fibers. Okay. So the determining factor is, okay, so if I'm replacing weather wire mesh a certain width or certain gauge, you know, I was going to try to get the same performance of the fibers as I would with my crack control steel. And that would be the intent of this. Okay. So this is an ASTM 1399 test, similar to the 1609, except it's a smaller beam. It's a 4x4 14 beam. And you load the concrete till it fails. And the failure point is here. You have a plate underneath the beam. And after it fails, you yank out the plate and you reload the curve. You're trying to find the area between A and D. Okay. In this case here, its average residual strength, so an ARS. Okay, so there's about a 10% correlation between the 1399 and the 1609 test, just to kind of show you. But either one would be good to show validation. The Australian round determinant panel test, the Astm 1550. So basically we have a 32-inch diameter, 3-inch thick hockey puck, where we basically ran this ram goes down right in the center, okay, and they'll start to form cracks around it. And this shows that let's say if I had weather wire mesh, it'd be difficult to put the weather wire mesh in a 4x4 14 or a 6x6 20 because I might have a single strand going through, so it's really not fair. So that's why we put it in the test like this. And you'll see this type of test in shotcrete, tunnels, and mines where they'll shoot into a panel and to see what performance level you're going to have out of the fibers versus the weather wire mesh. Okay. This shows a little bit of how it's laid out. 120 degrees between the supports. And it basically will start to crack like this. Going to see on those are some pretty hellacious cracks. I mean, but it's really good because if you're in a tunnel or a mine, it's about life safety, and you want that concrete to fail, but not crumble, right? Not to completely cave in on it, right? So it's holding it together. This is an Australian round determinant panel test, the 1550, comparing conventional fibers or plastic crack control fibers against weather wire mesh. As I said before, this is a deflection of 12 millimeters, right? Way up here. This is the performance of that versus conventional fiber, so it's way down here. It shows you that you don't have very good when you use plastic cracks versus here. So the intent would be not to replace this, only use macrofibers for that purpose. Applications of macrofibers or where they've been used, we basically came out back in 2002, and we tried to put them basically replacing some of the temperature and shrinkage steels for manholes, and precast elements, basically steps where it was difficult to put a lot of the crack control steel in there, and forming up mesh in the steps would be difficult. So we would put the fibers in for that, okay, to replace that steel. Okay. We did it for shotcrete, tunnels, mines, slope protection for trapezoidal channels, where they would have weather wire mesh in there. This way, here, there's really no load. It's just going to be holding it together. So we would put 3.5, 4 pounds in it, we'd be pretty much good. Driveways, radiant heat slabs, and then also for like a 2-inch overlay for a maintenance garage. So it's basically just to keep the fibers in there, keep the cracks tight. From a DOT perspective, this shows a little bit about some DOTs that have accepted this, basically in certain applications, not all of these, but in each state. But in these states, white toppings, which is concrete over asphalt, bonded overlays, concrete over concrete, driveway entrances, drainage ditches, bridge deck overlays, and full depth bridges. We've actually used fibers for that purpose. And the intent is basically to keep cracks tight. You're spending a lot of money on an average 300 cubic yard pour for a bridge, and you obviously don't want it to crack. So here in Missouri, where I'm from, we've got 3 inches of clear cover. So they're considering using macrosynthetic fibers for the purpose of keeping cracks tight in that 3 inches of upper crust of that bridge, right, to keep cracks tight there. So Illinois DOT did a white topping, 4 pounds per cubic yard. Again, concrete over asphalt. Augered it in. There. This is Route 13 in Iowa. I think it's kind of on the western part of the state near Des Moines. Going to see the different panels they have, but it turned out very good. Do it for curbs. They load the fibers in at the batch plant, okay? And you pop them in the truck. They come in roughly anywhere from 2 to 5 pound bags, and they're pulp and paper, so it dispenses in the truck. Probably the best way would be to put the fibers in first, and then you put the aggregates in, and if you have a pretty good aggregate abrasion to it, it'll bust up the bag, and then it mixes usually between 70 and 100 revolutions before it goes out to the job. So it's kind of the best way to do it. Now, you could tailgate the load. You could put them in at the tail of the load, but you still do need to mix them and make sure they're dispersed at the job. So finishing expectations for interior slabs, you basically use machines. Anytime you can use laser screed, power trowel, pan floats, you drive the fibers right into the paste, and you can have a beautiful finish where you won't even see any fibers at all. Now you could see them, they could protrude if you're hand finishing on the edges in between the control joints or saw cuts. So you, again, you want to minimize that anytime you can, okay? If you have, let's see, interior slabs without vibration, you do definitely have the potential to see the fibers increase, okay, without any vibration. For exterior, you would basically use a bull float in a light broom finish with several passes angled at 10% of the horizontal, meaning that if you ever seen fibers or ever seen concrete for exterior done, basically they'll bull float it, make it nice and smooth, and they'll turn the broom over and they'll just rip the surface. You obviously don't want that to happen because the fibers are right on the top of the paste. So if you do that, you'll just grab a bunch of fibers and it'll be a mess. Okay, so basically bull float it, wait till it's almost set, and then you put the broom to it, 10% to the horizontal, and then score it a couple of times until you get the consistency you need, and you'll minimize the amount of fibers. Okay, and the main thing is that, you know, you're always going to see some fibers for exterior, but it definitely won't be that many. But the main thing is you're going to be providing with good, a lot less cracks. Okay, and which is the primary intent of the product in the first place. So this just shows you a finished slab. You know, it almost looks like it's a burnish type finish. You don't see any fibers at all. There are some, you'll see if you've ever been to any of these warehouses, they're building these 1 million square foot warehouses with fibers at very, very high dosage rates. And you'll see, basically you won't see any fibers at all, and they're all in that slab. And I've seen a lot of them are dosage rate of 7 to 7.5 pounds per cubic yard. So if we can do that, we can do it for a lot of other applications as well. We're doing it on time. Okay, got a little bit. Okay, so this is a little bit about joining procedures and limitations. For interior or exterior, you know, typically you would say 2 to 3 feet times the thickness in inches. So if I've got a 6-inch thick slab, typically for interior, you might take it, say, 15 feet. For exterior, it would probably be something more like 12 feet, you know, as far as the joining. The base material basically, and again, it's a reaction of the concrete that supports it. So the K value is what we're looking at. So you have to make sure you have a good base anytime, really. You have to know the limitation in the restrained shrinkage. So if you're going to be attaching to any columns, obviously it's going to restrain right there. So you try to obviously want to separate it from that column, and then it'll provide a little bit more free shrinkage. Poly sheathing, it's always good to kind of put that on the subgrade and to let the concrete free shrink and then reduce any of that constraint. Zip strips around the exterior, making sure it doesn't grab a hold of the wall. Okay. Isolations by penetrations, any type of, you know, drains or something like that. You want to make sure that you're going to isolate around that so the concrete can free shrink around it. And then cut control joints deep enough where it will release that joint. And that's a big deal because from the standpoint, if I'm using fibers in my concrete, it has a very good job of worming their way across that joint. Okay, so you want to maybe cut the joints at D/3. So if it's a 6-inch thick slab, cut it down 2 inches, which is pretty deep. But again, you want to get that to release, because if it doesn't, you'll have a dominant joint effect, which is basically it'll carry that whole section with it until it finally does release in another location. Then you'll have a big, wider crack than you want it to appear. Okay. So here, these are some projects that we've done. Some interior jobs. Soft cut saw is always good to get on quicker. Finishing machines. Driving the fibers in the paste. This is a job in Carrollton, Texas, near Dallas, just north of Dallas. About a 2-mile path where they wanted to make sure that we keep the cracks tight in there. What we did, we replaced 6x6 2.9, and I was a little bit apprehensive about doing that just because they have expansive clays in there. But as it turned out, it worked out very, very well, and there's really no fibers or no issues as far as cracking in between the panels. We looked up close, and you can kind of look here, and almost looks like is a light medium broom finish. There's areas that that almost looks like there's fossils of where the fibers used to be, but there's nothing really sticking out. They will wear away through abrasion and UV eventually. So Macrofiber slab and grade design software, whether it's interior or exterior, you can use this software. It's pretty neat. Just the development was done at the University of Illinois, where we compared 5 pounds of fibers against 6x6 2.9 mesh. And as it turned out very, very well, we showed the comparison. We basically punched through this section, and you can kind of see how it kind of went up on the end, on the bottom right picture. And then we compared it against each other. Basically, we wanted to make sure, we wanted to validate that the performance of the fibers and the weather wire mesh were very similar. You can kind of see the blue line represents the macrofibers. Loaded till it fails, it cracked, reloaded again, and then finally it did fail at the very end, but it basically ended up at the same place. So 5 pounds versus 6x6 2.9 mesh. We turned it over and want to see as far as the size of the crack, and the high volume synthetic fiber or macrofiber kept the cracks very, very tight versus weather wire mesh was only 3/8. And basically how it does is you have fibers through and through, so it keeps the cracks tighter than a panel or weather wire mesh that's kind of going right through the center. This shows a little bit about unreinforced concrete. The maximum load of this was 135 kilonewtons. Again, unreinforced. You can kind of see as we crack that panel, what happened as far as the deflection. And then the next thing was, this is with weather wire mesh, so it did a good job of holding it together until it finally did fail. But the maximum load of this one was 200 kilonewtons, so it's 50% load increase of load carrying capacity just by using in weather wire mesh. Okay, and then we use macrosynthetic fibers, and the whole thing would crack. The monolith would go down, crack again, and it held together until it did finally fail. Maximum load of this was 195, so it was similar to as far as the load carrying capacity, but it did hold together. It kind of shows the whole panel reacts together, distributes. So the background of the software basically is that you have the applied load or flexural strength of the concrete plus the residual load gives you total load carrying capacity. So it's the intent is if I was going to design for a slab on ground, I might design for 600 PSI. I might have with my macrosynthetic fibers, say 150 PSI residual flex, so I could actually add them up and design for 750. That way I could either thin my slab up or increase my load carrying capacity. And that's the background of the software. Now you can use it for racking, wheel loads, uniform aligner wall loads. They have different type of load carrying cases, whether it's exterior for paving or interior. So it basically shows you it does have that capability to go anywhere. Slab design parameters, we're putting in compressive strength, subgrade factors or K value in there, safety factors for the concrete safety and variable dynamic loads. Okay. And then you also have the ACPA street pave software, which is it's relatively new. It's probably about 3 or 4 years into it, but you can use macrosynthetic fibers by checking a box when you start to use the street pave software, and it allows you to use the fibers in there and thin up the section. This is just a job in Edgewood, Texas. This is just an area just in Fort Worth where we were comparing weather wire mesh and what they would typically do on the roadway paving. We stopped the section, put the fibers in, and then we moved on from there. You can kind of see this is the area they left it alone. Put it in, augered it in, and put the panel in. So just a quick picture there. So it was in Fort Worth. So just real fast, I think I'm about done here. So a typical dosage rate for macrosynthetic fibers, 4 inches or greater, okay, for pedestrian loading, so 3.5 to 4 pounds. So you kind of see this is similarity of this as well as for vehicle traffic, 4 inches or greater for parking garages for loads of vehicle being say 12,000 pound vehicle for over 4 wheels, 4 pounds per cubic yard. 6 inches or greater for medium trucks, say 50,000 pounds trucks. Again, parking lots, 4 to 5 pounds, and then 8 inches or greater for heavy trucks, for loading docks, street paving, building drive lanes, so 4 pounds per cubic yard. I try to keep it there because the slump loss is a lot less. It's easier to work with in the field. You could use a higher dosage rate, but I'm trying to keep it low. Okay. So basically, to increase your chances of a successful project, try to invite the fiber supplier to your pre-con meeting, answer any questions that they might have in the field. Go through a test pour, kind of do a trial run. It's always good to do. And then go through on basically the best practices with your crew on how to mix, place, and finish the concrete. And that should hopefully get you there. The value proposition is you have to realize that there is a value proposition. You want to make sure that you can replace that crack and roll steel and you're giving a benefit to the owner. Okay. So if you can, typically what you're going to have is you replace that, you have the labor, material, overlap chairs with when you put crack control steel on a slab on ground, and you're putting in fibers, you just have the cost of the fibers only. That is it for me. I'm going to turn it over to Matt Norman, and Matt Norman's with Concrete Fiber Solutions, and hopefully he can give you some insight on the steel fiber end of the presentation. Thank you very much.
Bottom right corner where it says share. There you go.
What?
Okay, so you want to, no, you need to get up to there.
There we go. All right, hopefully everybody can hear me. Thanks, Larry, for the handoff, and Thayer, and thanks a lot for putting these webinars together. I know you're being very proactive within the IRMCA, and us members, we like that. So I'm Matt Norman. I'm with Concrete Fiber Solutions. We are a manufacturer of steel fiber for concrete. We're located right in Chicago, Illinois. And today I'm going to talk a little bit about steel fiber reinforced concrete. So, what is steel fiber? Specification ASTM A820 is what I usually point to. There are 5 types of steel fiber listed in the ASTM spec. Type 1 fibers, which are made from cold drawn wire. Type 2 fibers, which are made from sheet steel. The type 3 and 4 fibers aren't used very much. They're like a melt extract kind of process. And then there's a type 5 fiber, which is actually a cold drawn wire fiber, but it doesn't have a round profile. It has a semicircular profile, and that's the only real difference. Basically, your steel fiber is made from a high tensile strength, low carbon steel. It's always deformed for maximum bond within the concrete matrix. It is a discontinuous reinforcement, which Larry mentioned, and that is a key aspect. Steel fiber being discontinuous is used in many applications, but where it isn't used is in structural applications. If you're building a bridge deck and you're building your beams, you're not going to be using steel fiber. You're going to be using rebar continuous reinforcement, because you need that continuous reinforcement to pick up the load if that beam fails. And most structural engineers design these beams to fail. So that's what you're looking for. Where the steel fiber and fiber reinforcement in general works best is when you have some form of continuous reinforcement already present, which could be your subgrade for your slab, could be a composite metal deck. Those are areas, and then the steel fiber is utilized to carry the point loads, the rolling loads such as forklifts or semi-tractor trailers, and to provide crack control as well. Key aspect is that steel fiber and fiber reinforcement in general is a 3-dimensional reinforcement. So really what you're doing is you're placing a composite material when you're placing a fiber reinforced concrete. Whereas typically you'll place concrete and you'll put a layer of mesh or a layer of rebar in there. your reinforcement is in one plane and only in two directions. With steel fiber, you're three-dimensional. So your fibers are more efficiently located within the concrete. It imparts the properties of your fiber much better than regular reinforcement. So with steel fiber, it's a ductile product and it's providing ductility to a brittle matrix. We all know that concrete's very strong in compression, but it is weak in tension and flexure. And these applications that we talk about today are not in compression, they're in tension or flex. So if you can improve those properties, you can improve the performance of your concrete section. Many of the applications that we get into these days are slab on grade applications, distribution warehouses, manufacturing facilities, exterior paving, dock areas, things like that. One of the areas that we've gotten very involved in is the area of extended joint floors. And CFS has successfully extended joints on large warehouse slabs up to 125 feet with no interior saw cuts and no interior cracks. Multi-story composite deck construction, freezer refrigerated storage. I don't know if you've seen what's going on in the industry today, but based on the change in purchasing habits of individuals, there is a definite lack of freezer and refrigerated facilities in the United States. And it's one area that we feel is going to be a high growth area. Exterior pavement is a great application for fibers, both synthetic or steel. Steel fiber, being the fact that it is a steel fiber, can replace your reinforcing bars, can reinforce the joint itself. So it's an excellent application for exterior pavements. A question I always get is that of corrosion. The thing you need to think about with steel fiber is that each fiber is basically insulated from the other fiber within the concrete matrix. And the only fiber that actually corrodes within a concrete matrix like that is the fiber that's directly exposed to the atmosphere. So you might see on an exterior pavement, you might see a small pinpoint of rust from a fiber or a fiber that's exposed to the atmosphere, but the fibers that are inside the slab, they will not corrode. And unlike continuous reinforcement that creates almost like a battery effect with the free flow of electrons, the corrosion within a steel fiber reinforced exterior pavement will not propagate. And the other thing is that because the fibers are fairly fine, even if it does corrode, it doesn't change volume to the point where it will cause spalling of the concrete itself. And as a matter of fact, what it really does, it helps to bind that concrete together to the point where you see a minimization of potholing and spalling when it comes to that type of an application. The other area application that's really good these days is food processing. Within the food processing industry, one of the worst things you can have is bacteria growth and pathogen growth. And unfortunately, within a typical food processing slab, you have joints every 12.5 feet. Those are areas where bacteria can grow and infiltrate. And by utilizing a steel fiber extended type project or application, you minimize the number of joints, you minimize a lot of the pathogen bacteria growth. We've done a number of food processing projects for companies that they just love the idea of not having as many joints, because when they're washing down their machines and the floor slabs with 160 to 180 degree water, they know that there is a minimization of potential bacteria or pathogen growth. So some of the effects of steel fiber, Larry did a great job of showing a number of graphs showing the different test procedures that are available. But with steel fiber, you're going to see some increased flexural capacity of the concrete. You're going to see an improved fatigue endurance, improved impact resistance. you're going to actually, by imparting steel fiber within the slab, three-dimensionally from the subgrade all the way up close to the surface, you can impart a lot of the ductility of the steel into that brittle matrix. You can actually get concrete that has a more ductile nature to it, which means it will take cyclical loadings and the number of cyclical loadings better. It helps to arrest the microcracks that propagate within concrete, and it also helps to relieve some of the internal strain. I mean, here is a typical picture showing some steel fiber and showing you can see some microcracks. And as you know, as concrete shrinks, it cracks, but a macro crack that you see is nothing more than thousands and thousands of microcracks that have joined together. If you can arrest the growth or change the pathway of the growth of those microcracks, you can effectively reduce the number of macro cracks you see on a concrete section. And in this case, all of your microcracks propagate off the end of an aggregate. The steel fiber within that concrete section, or fiber in general, helps to arrest those microcracks that are trying to propagate. We talk, design considerations, as Larry mentioned, when we're designing a concrete section with steel fiber, we utilize Westergaard's equations for our design. We always look at what your subgrade reaction factor is. How good is your subgrade? What are your loading characteristics? What is the owner or the end user trying to accomplish? Do they have heavy point loads? Do they have heavy forklifts? Do they have semi-tractor trailers? What are we looking at as far as loading characteristics? What we do is we try to determine the slab thickness of the concrete based on an unreinforced section, so that we know that we have a thick enough slab, and then we determine our steel fiber dosage based on the type of application. Are you looking for shrinkage crack control? In that case, you're going to be at a lighter dosage of steel fiber. Are you looking for extended joints? In that case, you're going to be at a higher dosage. At 100-foot joint spacings, we're generally going to be around 65 pounds per yard of steel fiber. And what are you looking for as far as load transfer and edge protection? When you're talking about mixing, placing, and finishing of steel fiber reinforced concrete, steel fiber has a specific gravity of 7.86, so it's much heavier, and it's very much like the aggregate. When you hit it with vibration, the steel fibers will migrate below the surface. The advent of the laser screed was huge when it comes to being able to produce larger floors and be able to produce larger daily pours, but also the laser screed with the vibrating head and the auger, it applies a tremendous amount of surface vibration, and that helps with the migration or the pushing of the steel fiber down below the surface. We talked a little bit about corrosion. Steel fiber is discontinuous. The paste helps to isolate the fiber. When it comes to mixing, really all you need is about 70 to 75 revolutions of the drum on high speed in order to homogeneously distribute the steel fiber throughout the mix. You can either add the fibers ahead of time within the concrete ready mix drum or afterwards. Either way, a lot of it depends on the application. A lot of it depends on whether you have a dry batch plant or a central mix plant. But we always work with our clients to consult both on the design as well as the utilization of equipment for mixing, placing, and finishing. We work with the contractors when it comes to how do you work with this material. We will work with the engineer on the mix design, on the submittals. So we kind of take a holistic view when it comes to the utilization of our product or steel fiber with our clients. There's really no additional wear on the mixing trucks or the trowel machines, unbeknownst to a lot of people out in the industry. The steel fiber that's generally used today by most manufacturers is a high carbon or a low carbon, high tensile strength material, and it's a fairly ductile material. It's not a real hard material, which means it doesn't provide any more abrasion on the equipment than the aggregate itself would. So if you're not finding a lot of steel fibers at the surface, you're not going to find a lot of wear on your trowel machines. And even in the fins of your mixing trucks, it doesn't provide any additional wear on those fins. So it really isn't an issue from that standpoint. You can provide a hard trowel burnish finish. We see it all the time. And for when it comes to exterior, obviously you're going to do some type of a textured brush finish. We recommend that you do basically a single pass with your brush, angled against the grain so that you come along and provide your texture, and try not to pick up so many fibers in that case or that application. When it comes to adding steel fiber, we don't package in soluble bags. We package in 50-pound boxes. So we're going to utilize some type of a conveyor system. In this case, this was a project we did down in Mount Vernon, Illinois for Continental Tire. The concrete supplier was Concrete Supply of Illinois. And they utilized a conveyor at the batch plant to add the steel fiber to the mix. You can do a scaffold system. This was a project that we did up in Rockford, Illinois for Woodward Corporation. Rogers Ready Mix was the ready mix supplier on this job. They erected a scaffold system and were able to charge 2 trucks at a time for that project. That was an extended joint floor where the joint spacing was 110 feet by 110 feet. Finishing, obviously the laser screed is one of the best ways to go, but if you're utilizing a truss screed or a vibra strike, either way, the vibration at the surface is very critical. It provides sufficient vibration to consolidate the fibers. You obviously want to vibrate the edges of your concrete section with your point vibrator. Pans first for your flatness, blades secondly for your hardness and your trowel finish. And then as Larry mentioned, it is critical that on a fiber reinforced slab, and specifically on a steel fiber reinforced slab, that you cut that slab 1/3 the depth. So if you're at 6 inches, you're at 2 inches. If you're at 7, you're at 2 3/8. If you're at 10 inches, you're going to be, 3 1/3 inches deep. It may turn out that on thicker slabs, you're not going to be using an early cut saw. You may be using a highway saw, but it is important that you cut that joint sufficiently deep enough in order to weaken that plane so that your crack forms where you want it to. Otherwise, as Larry had mentioned, you can transfer that a couple joints down and get what they call a dominant joint. But we hope that all these joints activate correctly. When it comes to finishing, as we talked about, the laser screed, all typical procedures are pretty much used. This is a exterior paving project that we did up in the West Chicago area. In this case, they're using the laser screed to strike it off, a bull float to float it, and then right behind it coming with their brush. Talking about projects, exterior paving is an excellent application for steel fiber reinforcing. This is that Enterprise West project in West Chicago, Illinois that we just completed. It's roughly around 400,000 square feet of exterior pavement. We did not only the truck areas, but we did the car parking areas as well. The fiber dosage was 35 pounds per yard, and we eliminated a number 3 rebar at 18 inches on center in this type of an application. Slab thickness for the truck area was 7 inches thick. There's a number of projects in the Chicago market where we have done the extended joint floors. This is one for Prologis down in Lockport, Illinois. Lockport building number 1, 2, and 3 are all Slab extended joint floors. The joints on those floors are 104 feet by 108 feet with no interior panels or no interior saw cuts. Now, the key to producing this type of a floor is that you want your panels to be able to move freely. So you're going to put a slip sheet on the subgrade. It's not a vapor barrier, it's a slip sheet. That's what we name it as. It's anywhere from 4 to 6 mil thick polyethylene sheeting, and it's simply there to reduce the coefficient of friction between the subgrade and the slab. You're going to isolate your columns by wrapping them with at least 1 inch of closed cell compressive material. That isolates your column from your slab and allows the slab to move freely. You have to address any reentrant corners, as well as any protrusions through the slab, such as a drain cleanout, something along those lines, electrical cables coming through. All of those have to be isolated. Now, on your drain cleanouts, what you're going to want to do is you want to pour right up against the drain cleanout to give it strength and stability. So what we do is you dig down about 2 feet into the subgrade and you wrap the actual PVC piping coming up to the drain cleanout so that that piping can move as your slab shrinks. You should expect on these wide slab floors to get much wider joints than you would normally get. What we try to do is control the shrinkage of the mix by specifying a 0.04% shrinkage number or less based on the Astm C157 test. So we will do shrinkage testing before to confirm the mix design meets that. And at the same time, what you're going to want to do is delay the fill process of the joints as long as you potentially can. As we know, a slab shrinks for a long time. An 8-inch slab can shrink for up to 2 years. Now, obviously, the majority of the shrinkage occurs within the first 90 to 120 to 200 days, but there is still minimal shrinkage further out. If you can delay your joint filling as long as you can, then it will allow for the potential to maybe not readdress that joint fill a year down the road. This is an interesting project we did. We just completed this actually down in Morton, Illinois, near Peoria. This is for Caterpillar. This is an existing building that they're putting in a robotic picking system for a new rack configuration. So what they were looking for is they were looking for an F-min 70 floor. And what they elected to do was, rather than taking out the old floor, we put in a 5-inch unbonded overlay. We poured it in long, narrow strips and used a truss screed on it with no joints throughout those strips. 70 pounds per cubic yard of our type 2 fiber, which gets roughly about 8,500 fibers per pound. So at 70 pounds per yard, you've got roughly 600,000 fibers per yard of concrete in that mix. Yet I walked that slab just recently and you'd be hard pressed to find a fiber on the surface. Turned out beautifully. The company that's doing the robotic system is a company called AutoStore. We've partnered with them on a number of projects doing just this, which is the robotic picking systems, some overlays, some full depth brand new facilities. This is the Woodward project in Rockford, Illinois. This is one of the oldest extended joint floors in the Chicago market. It's roughly about 8 years old now. 110 foot by 110 foot joint spacing. I walked that floor just a few months ago, and there's one crack on the floor, and it's over by the bathroom, coming off of one of the pipes. But interior wise, I was hard pressed to find a single crack on that floor. And this is a heavy industrial facility. Woodward manufactures, for lack of a better description, the carburetors for jet engines. So a lot of hard aluminum block, as well as machines, stamping machines, things like that. And then CFS have basically come up with a series of construction systems that we've put together that we can help engineers with. And they all deal with applications that are very prevalent today in the marketplace: extended joint floors, cold and freezer floors, pavements, and multi-story high-rise buildings. Just to give you an example, within the downtown Chicago market, we now have 110 North Wacker, the brand new building downtown on the river, which is a steel fiber reinforced composite metal deck, high-rise, 57 stories. We're currently working on the 320 South Canal building. And then as well, there is the new Salesforce Tower that has a steel fiber lightweight specification in it on composite metal deck. So the multi-story high-rise industry is an excellent application for steel fiber as well. And then just to give you a little feel for costs, we did an expansion for White Wave Foods. It was 141,000 square feet. And originally they were going to be utilizing a rebar design. We went in and helped the engineer to redesign to steel fiber. So the rebar design basically looked like this. Rebar cost, pre-pour preparation, chairs, things like that. They had to pump the concrete based on, the rebar mats, the construction joints. The fact that the saw cuts were within 12.5 feet of each other, and then the joint filler for all of the joints that were in the floor. We redesigned it with the CFS steel fiber, put a slip sheet on the floor, 60 pounds per cubic yard of steel fiber, eliminated the rebar, eliminated the prep for the pour, didn't have to pump. We were able to shoot dump the concrete. Dowel baskets on an extended joint floor, you're going to have diamond dowels at construction joints, and you're going to definitely have some form of load transfer at every saw joint because of the distance between the joints. The saw cuts, the joint filler, there was a savings. And then on top of that, originally they had proposed 14 days to produce this floor. We were able to do it in 7. So that concludes basically my portion of the program. Thanks very much, and I'll turn it back over to Larry.
Thank you, Matt. I appreciate it. Good job, Larry and Matt. We're going to take a couple questions that was asked. This goes to Matt and Larry. Regarding the fiber reinforcement, have you heard of any issues crushing recycled fiber reinforced concrete, gradation control, post-use compaction dust?
I have not.
I haven't either. I mean, I don't really see it being a big issue, just because when you say you're pulverizing the material, it's probably not going to be a big deal. If the fibers are even attached to any of the old paste and the crushed aggregate. So that's just my opinion on that.
All right, we got one more question. When adding the fiber bag, do you throw the entire bag into the drum or slit the bag, then throw the bag into the drum?
We have pulp and paper from the synthetic side. I mean, I've seen it done both ways, but for the most part, it is designed to be popped in right into the truck, and then it will mesh with the mix and not really have any issues. There are some times when you have, let's just say, a lot of fibers and you have not a lot of paste to work with, or you have a small aggregate in your in your mix where you might not have a very good abrasion, then you could maybe score up the bags and let them get mixed. It makes it a little bit easier than having the whole bag put in there.
Okay.
Yeah, and when it comes to the steel fibers, you know, we've tried the disposable bags. It really doesn't work because, you know, our dosage rates and the weight of the steel fiber. So we package in cardboard boxes, and you open the box and just place the fiber right into the mix through the conveyor or through some kind of scaffold system, or however you can to deliver it right into the truck.
All right, we got 2 more questions popped up. Any thoughts on UHPC mixes with fibers?
Yeah, actually, we've done some research with a couple of labs on ultra high performance concrete. I mean, one of the things that they've been, you know, obviously with the ultra high performance concrete, you know, when you're at 20 to 25,000 PSI, when that concrete fails, it's a very catastrophic failure. So there has been a number of research studies done utilizing what we call microfiber. We manufacture a fiber, a steel fiber that's anywhere from 1 to 3 millimeters in length. And you add that to your ultra high performance concrete. And what it does is when the ultra high performance concrete fails, the failure is not as catastrophic, it's more predictable. So we worked with a little bit with Wisjani Elsner on some testing with UHPC and fibers, and frankly, it was pretty positive as far as the results were concerned.
Okay, Larry, you have any comments?
Yeah, we were actually going to try to do some research at the University of Connecticut, and it never did pan out as far as we had a macrosynthetic fiber that was kind of designed for high volume, you know, 15 to 22 pounds per cubic yard, which is like around 1.5% by volume. We never did get the research completed. But they were actually, the steel fibers is kind of more suited, I think, for UHPC, just because on the top end, when that concrete fractures, the steel does a better job of kind of holding things together, you know, as far as at that fracture point. So I wasn't sure, I wasn't giving a lot of, I wasn't sure if it was going to work anyway, but we were going to give it a shot. Okay.
Okay. We have another question here. Can you use macrosynthetics with post-tension residential slabs?
If the intent of the post-tension is for structural purposes, I wouldn't replace it from that standpoint. I think maybe like in Arizona, I know they have a lot of post-tension. It's just, you know, primarily designed to get replace the crack control steel.
Matt, you have a comment on that or no?
Well, I mean, when I was with Novacon Steel Fibers back in the late 90s, we did a project with the University of Illinois out at Rockford International Airport, where they poured an airport taxiway. Now, this was pretty interesting because it was steel fiber reinforced, it was post-tensioned, and they used type K expansive cement. And they took what would have normally been a 16-inch thick slab and reduced it down to almost 8 inches. It worked very well, but the cost for it was, you know, was to the point where it really wasn't a practical application. So that was interesting. I mean, so, you know, I mean, we've participated in a number of different types of projects like that. I know that steel fiber is used in expansive concrete fairly regular these days. It used to be that they thought you had to use continuous reinforcement to control the expansive process of the expansion concrete, but steel fiber actually does a great job on that in controlling the expansion. So we will participate in expansive type concrete as well as typical type 1 and type 2 Portland cement concrete.
All right, and there's one last question here. This person put one other concern We outsource crushing our recycled concrete. Any concerns from crushing contractors regarding wear and tear due to steel fibers?
I wouldn't say so because, like I said, we use a high tensile strength, low carbon steel. It's a very ductile steel. It's a soft steel. And when it comes to abrasion and wear, it's really not any more abrasive than the aggregate. Now, the one thing that won't happen is, you can crush the rock into, smaller powder and things like that. Your steel fiber is not going to crush into that. It's just going to, it's going to fold or bend or whatever. So that's the only situation I would look at.
All right. Larry, this one's for you. Can Larry give a quick 1-minute pros and cons of fibrillated versus monofilament, typical dosage of one versus the other from controlling plastic shrinkage cracks?
Okay, so basically, to validate the performance of a micro-type fiber, which that's what these two are, we use an Astm 1579 test. Basically, kind of like blow air across like a pan, trying to see the performance of the fiber from the early age crack control standpoint. So a microfiber, a fibrillated type versus monofilament. Fibrillated, typically, you have like a pound or pound and a half. See a lot of specifications. It will give you that plastic crack control performance. It will also give you a little bit of post crack control performance, probably somewhere in the neighborhood of 45 or 50 psi residual flexural strength. If you double the dosage rate, you might get something around 80, and which is kind of on the bottom end of what you would have with a macrofiber or what you would get with crack control steel, the very small end. But you also have issues with respect, if you're going to double the dosage rate, you'd have potential issues with finishability. Okay, I really wouldn't put 3 pounds in, but if you did, you'd have to make sure you have enough super and stuff in there. A monofilament typically is a half a pound or a pound per cubic yard. Most of the time I'll see, again, half a pound works very, very well. We know that this type of fiber is just for plastic crack control. It's not going to give you very much residual flexural strength, maybe 10 psi. I think I showed you that in a diagram. So we're not going to use it for the wrong reason, okay? So a lot of times we see sometimes, a pound and a half is replacing crack control steel. I don't condone it. I still think you should use a macrofiber for that application. And that's why the monofilament is a good way to say, this is what this is good for. And then the pound and a half is also good for plastic cracks, but try not to use it for replacing that crack control steel. Sorry I think it was over a minute, but hopefully that helped a little bit.
Yeah, thanks, Larry. All right, with that, we're going to close out the webinar. We have our next webinar on May 5th, which will be concrete overlays over existing asphalt parking lots, right? We see IDOT, we see a lot of private sector work with concrete overlays. This is a hot topic and a good answer for the engineering community to asphalt parking lots that are falling apart and need repairs. The registration will open on Monday, April 26th. Don Clem from the National Ready Mix Concrete Association will be the speaker. And at any point, you can always contact me. My contact information is there. We offer free engineering assistance. Today, you heard from 2 of the Irmc members that supply fibers. We have several other members that supply fibers as well. If you have a project and you want to explore using fibers on there, you can start with calling me. And based on the area of your project, I will get you in touch with the fiber suppliers that do that work. Again, we're on LinkedIn. We're advertising these webinars and sharing technical information and articles. And on Facebook and Instagram, we're doing our IRMCA member spotlight. So if you're active on social media, please look us up and follow us. And with that, I'd like to thank everybody again for attending our webinar, and we'll see you on May 5th.
Thanks, Darren.
Yep. Thank you, everybody.
Thank you.